In this short video, we are going to analyze the effects of a binding price floor. Let's suppose that the demand and supply curves in the market for sugarcane are given by quantity demanded equals 16 minus 0.5 P and quantity supplied equals P minus 8. In this scenario, Q is bushels of sugarcane in thousands. That turns out to be important later, and P is the price per bushel in dollars. We are told that in the absence of any government intervention, the equilibrium in this market is 8,000 bushels of sugarcane and a price of $16 per bushel. Now we're going to suppose that the government institutes a price floor of $20. We want to determine the maximum possible producer surplus as well as the minimum possible producer surplus when this policy is in place. So what do we need to know to answer this question? We need to know the demand curve, the supply curve, as well as the size of the price floor. Let's solve this question. So we know a lot of things. We know the demand curve, the supply curve, the equilibrium price and quantity in the absence of any government intervention, as well as the size of the price floor, $20. We are trying to find the maximum and minimum possible producer surplus when this price floor is in place. The first thing that we need to do is we need to figure out how many units are supplied and how many units are demanded at this artificially high price. How do I know it's artificially high? Because I've taken a look at what I know. The floor is set at 20 and the equilibrium is 16. So we have a binding floor. How do we figure out the supply and demand? We just plug $20 into the supply curve and into the demand curve. So the quantity supplied is equal to 20 minus 8, or 12. And the quantity demanded is equal to 16 minus 0.5 times 20. Well, 16 minus 10 is 6. So we could say that the quantity supplied is 12,000 bushels and the quantity demanded is 6,000 bushels. So we have a surplus because the price is artificially high. In order to find the maximum possible surplus, we need to understand where this occurs. It's going to occur when the 6,000 units demanded are supplied by the sellers with the lowest cost, because then we get the biggest difference between the price and the sort of willingness to sell, we'll call it. Who are these sellers? These are the sellers with the lowest cost, which means, in particular, they're those along the supply curve from Q equals 0 to Q equals 6. It can help you to visualize a supply curve. Supply curves are upward sloping, representing the sort of increasing costs. In order to maximize producer surplus, we need to be looking at the lowest cost producers, the one on the lowest part of the supply curve. What does this look like? It looks like this. So just some details. I have graphed the demand curve. It intersects the p-axis at 32, because when the price is 32, quantity demanded goes to 0. It intersects the quantity axis at 16. Similarly, the supply curve intersects the price axis at 8, because when the price is 8, quantity supplied goes to 0, and it's upward sloping. I've put the price floor in place at $20, and I've labeled what we know, that at a price of $20, 6,000 units are demanded and 12,000 units are supplied. It turns out that the maximum possible producer surplus equals this purple shaded region, the area below the price floor and above supply from 0 to 6, where we're like forcing the surplus to be coming from the lowest cost producers, the one on the lowest portion of the supply curve. If we want to compute the area of this purple trapezoid, we need to find the cost of the seller of the 6,000th bushel. Now the graph, this is already labeled at 14, but what I'm talking about is if, say, we were taking an exam or working out a homework problem and we had simply sketched this, we wouldn't know this value. And without this value 14, we're not able to like add the area of the rectangle to the area of the triangle. So we need to sort of sketch the picture, identify that we are having the first 6,000 sellers supply this good, but we need to know what is the cost to that final seller, that 6,000th seller. How do we find this? We just take the supply curve, P minus 8, and we set it equal to 6. So we say 6 is equal to P minus 8. We can add 8 to both sides and conclude that the cost, in this case the price, of the 6,000th bushel is $14. Now that we know that value, we can compute the producer surplus as the area of this purple trapezoid. So that's going to be equal to 1/2. So I'm starting by finding the area of this triangle here. So 1/2 14 minus 8, that's the height of the triangle, times 6,000. Be careful with your units here. Plus, now we need to find the area of the rectangle. So notice that 14 mattered that we solved for before. Plus, the height of that rectangle is 20 minus 14 times 6,000. So we get 1/2 times 6 times 6,000 plus 20 minus 14 is 6 times 6,000. So we have 3 times 6,000 plus 6 times 6,000. That's 18,000 plus 36,000, which is 54,000. So the maximum possible producer surplus is this purple shaded region where the units are supplied by the lower part of the supply curve, the first 6,000. And we needed to do that little bit of extra work to figure out that 14 value before we compute this area. Now we want to find the minimum possible producer surplus. That is going to occur when our 6,000 units demanded, from the math that we did earlier, are not supplied by the lowest cost sellers. Instead, they're supplied by the highest cost sellers. Who are these high cost sellers? They're not the ones on the bottom part of the supply curve. Instead, they're the 6,000 sellers with the highest cost that is still less than the price floor of $20. So in particular, it's going to be those along the supply curve from Q equals 6 to Q equals 12. So what does this minimum possible producer surplus look like? It turns out to be this purple shaded triangle. Here, instead of having our lowest cost 6,000 sellers supplying this good, we have slid up the supply curve and we found the highest cost 6,000 suppliers. So we're in the upper portion of the supply curve. Now keep in mind, we haven't gone like up here because up here, those suppliers, their cost is too high relative to the price. So we're looking at the 6,000 units on the highest possible portion of the supply curve, and the producer surplus is just that purple shaded region. Now, technically, if you were solving this not with a graph already provided, but if we were building the sketch, we would need to find the cost of the seller of the 6,000th bushel. Now, we've actually already done this when we were talking about the maximum possible producer surplus, but we can imagine a situation where on an exam we were not asked for the maximum, only the minimum. So we would need to identify that 6,000 units were demanded and that those 6,000 units were going to be supplied not by the low portion, but the high portion of the supply curve, this part here. And we would say, hey, but I need to know this value. I need to know the cost or the height of the supply curve when quantity is 6. How would we do this? We would simply set our quantity supplied, P minus 8, equal to 6, and solve for P. And we would get that P is equal to 14. Now we can see that that's true because I've graphed it for you. Now the final step is just to compute the area of this purple shaded triangle. That's the minimum possible producer surplus. Once we find this 14 value, solving this is very simple. Producer surplus is equal to 1/2 times 20 minus 14, that's the height of the triangle. And the base of the triangle is 12,000 minus 6,000. Now, you already knew that this was going to be 6,000 because we know we're selling 6,000 units, but I've just sort of written it all out for the sake of being completely transparent about the work. So we end up with 1/2 times 6 times 6,000, which is equal to 18,000. Keep in mind that the maximum possible producer surplus was 54,000. So we have a very big difference in producer surplus depending on whether we have the right producers supplying the good or the wrong producers supplying the good.